Section 8.4, Proportionality Theorems. Our essential question: what proportionality relationship exists in a triangle intersected by an angle bisector or a line parallel to a side? Our first theorem, triangle proportionality theorem: if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So looking at this, they tell me that TU and QS are parallel. So then these sides, QT, QR, and SR, are divided proportionally. So I have TR over QT equals RU over SU. Okay. There are different ways you can set this up. The key thing is that you're cross multiplying the same thing. So based on the theorem, we kept the two sides together. But a lot of times if I was setting this up, if I had numbers here, I would do this over this and this over this. So I just use the fractions they give me. Okay, and that will work. The converse of this works as well. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. So if they give me RT to TQ and equal RU to US, then I know that TU and QS are parallel. So example 1, in the diagram, QS is parallel to UT, RQ is 10, RS is 12, and ST is 6. We want to find QU. So just set up the fractions. And again, I would just divide this as fractions. I have 10 over X. I have 12 over 6. I can reduce if it's helpful. Here my numbers aren't that bad, so I'll just cross multiply. 12x equals 60. X equals 5. Example 2 asks us to determine whether QT is parallel to RS. So instead of finding a side, checking to see if my sides work. So if we follow the rule, the theorem, we do 18 over 38 and 36 over 80. Again, I normally just set up the fraction I see, because here I'll be cross multiplying the same things. Okay. Either way, 18 times 80 is getting multiplied and 36 times 38. So I just went this way and that way. Now, we should reduce this to C, but some of that is a matter of how much you can see. 18 over 36, that reduces to 1/2. Half of 80 is not 38. So this definitely does not work. So I'm just going to put no there. If you don't see that, then you would want to start by reducing and see what they reduce to. As soon as you see something where it doesn't work, then you can say no, or if you know it, as soon as you know it does work, you can put yes. Then related to this, we have the three parallel lines theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. So UW to YW is what they give us here. So then VX to XZ would be our other proportion. And this works the same way. Instead of going to a point, I'm going to a line, so it still works. You can actually extend this out. Our theorem says 3 lines. You could do this with as many parallel lines as you would have. You would just want to watch that you're only matching up specific parts. Then looking at our triangle angle bisector theorem, if a ray bisects an angle of a triangle, then it divides the opposite side segments whose lengths are proportional to the lengths of the other two sides. So here AD and DB match up with BC. Well, I said that upside down. AD and DB match up with AC and BC. So AC over BC. Okay. This one a lot of times is how you want to set it up. I can match up the same part on the opposite sides, which some people find easier. So I could say AC over AD is equal to BC over BD. Again, I would be cross multiplying the same thing, so that would work. Example 3 asks us to find the length of AB. So here we have three parallel lines. We're doing the bottom theorem on the other side. We have 24 over 27 equals 32 over x. Again, you can cross multiply this. I reduced, so I said 24 and 29. I have a 3 that goes into both of those. So that gives me 8 over 9 equals 32 over x. So when I cross multiply, I get 8x equals 288. So x is 36. Example 4. Now the thing to watch on a problem like example 4 is what they're giving me versus what I want. Okay, I want to match up the parts. I want to match up 8x, 12, and GF. They don't give me GF, they give me a 14. So I'm going to have to think of this in relationship to this. If this was a 5, to get this side, you would do 14 minus 5. So what I want to do here is 14 minus x. So my setup, 8 over x. All right, and again, I go a little different than what the theorem says. I stay on the same side of this line. So I do 8 to x and 12 to this. That gives me 14 minus x. So when I cross multiply here, now the advantage of doing it the way they do it up above is I could reduce, but I find it easier to do the setup there. Cross multiply, I have 12x. Make sure I distribute the 8. So I have 112 minus 8x. Add 8x to both sides. You get 20x equals 112. So x is 5.6. Okay, the try one, they made, it looks hard because it has a square root there, but basically they made this ridiculously easy. We have 1 over root 2 equals 1 over our unknown. The tops are the same, so the bottoms are going to be the same. When I cross multiply, I just get x is root 2. Then our last problem is, if you think about it the correct way, is not that hard. You're basically looking at different triangles and you're looking at different lines where you have proportionality. The problem is that most people have is there's a lot of numbers here and it's keeping things straight. My suggestion on this is, if you're looking at the lines that are parallel, deal with the triangles. Make sure you're looking at whole sides in those triangles. If you're dealing with the parts that are on the sides, right, or the lines that are cut, then deal with just the part of the line. So the first one they give me is GF. GF is on the outside. So I'm just going to set up a proportion here based on my numbers. I have 6 and this unknown, which we're going to call x, and 4 and 6. So I just do 6 over x equals 4 over 6. I cross multiply, get 4x equals 36. So x is 9. Then the next one, FC. FC is here. So now I want to deal with my whole triangle. So this side matches with this side. So I have 5 over y. Then I want whole sides of a triangle. You could use AF, but if you messed up one, that's going to be messed up. So the best bet is to use stuff that they give you if you can. So the 5 is this triangle. That means that matches up with a 4. The y is this triangle. So 4 plus 6 is 10. So when I cross multiply there, I get 50 equals 4y. That gets me a y of 12.5. ED, we're now looking at the bottom one. So I'm going to call Z. Again, I want to use numbers I already have. So I could use the triangle we just solved for, but I'm going to use the small triangle at the top. So I'm going to say that the 5 and the Z match up. And again, if you set these up differently, but you're cross multiplying the same things, that is fine. Okay, and again, with 3 triangles, there's different similar triangles we can match up. But I want to match the 5 and the Z. So this triangle, this side is still 4. But now the whole length over here, 4 plus 6 plus 4, is 14. Cross multiply there. I get 4Z equals 70. So Z is 17.5. And then the last thing they asked me for is FE. Okay, FE is here. I'll call that W. Okay. So now I need to match up. I could match up whole sides and subtract. I'm going to match up parts. So this is one I have to use something I found here. I want to use the 9. So I'm going to do 9, 6, W, and 4. So I set that up as 9 over W equals 6 over 4. So 6W equals 36. And W is 6. And that is solving for those parts.